Hello, good afternoon. Can you hear me? Let me put in the chat. Okay, thank you for your feedback. I'll put video panel on. I'll remove hide the video panel, hide the floating meeting. Okay, so excellent. So let me see whether we have enough people here. Okay, so welcome everyone. Welcome again. So excellent, excellent. I'm sharing my screen right now and it's being recorded. My name is Yan-Chuan Chen. I'm a professor of mechatronics in mechanical engineering department. So everyone is here? That's great. That's great. So welcome to spring 2021. I feel very excited to have all of you here. So according to our website here, let me move this one here. According to the people section, you see my screen, right? So I have 60 students and 2 TAs, 1 observer. And this is week 1. We don't have lab and we don't have office hour. We're starting from next week, okay? I already gave you the assignments, okay? Homework 1. And every lecture, like in every lecture, now you can access the quiz. And you have until midnight to submit your quiz. It's used as attendance evidence, okay? And you have to do this one. It's counted towards your final grades, okay? So the main objectives for today's lecture is to go through our syllabus, express our expectations. So I also made what I called a course offering log or diary, okay? So I'm putting all this IDs here, but I suggest you get through the Zoom session from this one, from here, okay? From here, every day. Every time you just check what are the Zoom sessions waiting for you. So lectures are synced. I'm going to give lectures twice a week until the end of the semester. Okay. Our last lecture is May 7th. Okay. Probably we are not going to give lecture, just do a review. Okay. So here is our real thing here. Do you have access to your CAT course? You can get the syllabus. Okay. I can see some students still connecting, like Gabriel, still connecting the audio. So I'm monitoring the chat, okay? I'm monitoring the chat box. If you have anything, please type into the chat box. I'll respond you. You can also open your mic and directly ask questions. You can interrupt me, no problem. On the other hand, I know some of you may have some different issues. So it's okay, you miss 1 or 2 classes, but don't form a pattern, okay? I can see it, okay? So attending lecture is a good habit to be to get a good grades. So when you watch it, it's never like nice as attending synchronous lectures. So I'm going to go through with you about Mechatronics syllabus. After that, I'm going to go through a few slides introducing what is mechatronics, what's in the mechatronics, and why we must study mechatronics. I know that this sounds like the course is required. I think this should be required. But however, ME has a very broad topics. So for example, you have emphasis on heat transfer, thermal systems. You have emphasis on like multi-body dynamics, mechanism design, or manufacturing. So here we have dynamics, automation, and controls. Is another emphasis area. So mechatronics is a synergistic. So let me do this. I think I can get something here. So this is the word you should remember, called synergistic. Okay, synergistic. Mechatronics is a synergistic combination of precision mechanics, electronics, controls, and computer engineering. Okay, computer engineering. So you have 4 aspects. So mechatronics is going through a process of integrated design. So this is another term, integrated. Okay, we are going to go through this one later, today's lecture. So you should be able to handle a wide range of technologies, okay, in sensors, actuators, interface hardware, control systems, analog digital electronics, software engineering, and concurrent design. Okay, so what we are going to do is not to pursue an in-depth coverage. On the other hand, we cover all the foundations. So this is a course called Foundations of Mechatronics. Okay. Over the years, I started my career in UC Merced in 2012. Okay, so it's been my 9th year. Okay, it's been my 9th year. I'm thinking about mechatronics too, so more advanced topics. So this is, again, this is the foundation of class, okay? So we are going to cover all the key topics in mechatronics. So you are ready for the career. And I believe this course will make a big difference in your job market competitive edge. So I put a movie I'll invite you to watch in the cover page of our course. It's a wonderful, wonderful talk. I watched it multiple times. So please enjoy and talk about it. So my message here today is mechatronics is the foundation for that digital transformation, industrial revolution wave number 3, okay? So you guys are the lucky generation having the new industrial revolution ahead of you, okay? So we are going to have very rigorous exercise, homework, labs, and we are going to do a case study in the lab. So it's a lab intensive course. Okay, lab intensive course. You earn 4 credits. Okay, what does that mean? We have a face-to-face 150 minutes lectures per week. That's 275 lectures, like Wednesday and Friday. You also have another 3 hours lab session per week. So also you need 3 extra hours for self-study, book reading, homework, literature review, and so on and so forth. So my submission is you have to invest at least 9 hours per week in this course to earn the 4 credits. Okay, 9 meaning minimum 9, okay? Minimum 9 hours, okay? So that's a time commitment. So let's talk about it. 9 minimum hours per week on this course. So I will be able to see how many hours you spend on the web. So like I click the people section. So in here, you will be able to see total activities, okay? So you are going to see who spent more time on this. I think I spent already this amount of time, okay? I'm on the top right now. There are some students never even logged in, I can see that. That's not a good sign, okay? You're not going to impress me by leave here empty. Daniel and Melissa, I don't see any recording here. And many others. It's okay. You can catch up later, okay? You can catch up later. And the organization of this one is you should check the files. And we have homework lab, notes, we have weekly, I put files in here. And I have videos here. We are going to watch some videos today. Then next week, then I'm going to add more. And the quizzes. So this is today's quiz. You should download a copy in a local one. You can, using your electronic stylus. Do you see, guys? I have a stylus in here. So let me see if I can see myself. Wait, yes, I can see myself. I'll do this way so you can see me better. So this is a pen, so I can write on the, so you can write on top of the file, or you print out and then you write on the hard copy, then you scan. I guess you know how to do this type of work. I give you the doc file, so you can also directly write on the doc file and save into PDF and upload. Okay. Remember, every lecture, we are going to have a quiz. Okay, around our topics lectured. So before the end of the day, at midnight, 12 o'clock. Okay. Okay. So let's go back to our syllabus. So I want to mention one point that you should feel proud of yourself, okay? Why? Okay, why? It's because the prerequisites, we only need circuit theory and statics dynamics, okay? So you should feel proud of yourself. You are learning mechatronics. We are using the lowest possible prerequisites for mechatronics course, okay? There are a few courses missing between these prerequisites and mechatronics. So you should feel proud that we are using the minimum prerequisites for mechatronics. So nobody in the world doing the same as us, okay? So from that perspective, some of you feel very tough and dragging you, don't feel very comfortable. That's a good sign. You are learning. You feel uncomfortable, that's learning. Even, excuse me, if you're comfortable, what's that? Is that a learning? Sometimes. But if you feel really comfortable, that's not learning. It's called what? It's called entertainment, okay? No, the quizzes are simple. Quizzes are simple. It's just a quick calculation. You'll see it. So just yes or no, some statement. If you, or I'll mention that I said this is in the quiz. Okay, I'll mention that. Okay. So it's minimum. It's easiest. It's not supposed to take you a long time. So it serves the purpose of attendance check. And also serves as a personal memory. It's like a diary for you to. So then you compile all your quizzes together. You go through your quizzes. You feel proud of yourself. Wow, I didn't know I learned so much. Okay, just for looking at the quizzes. Okay, good. Feel free to ask questions. Okay, I'm monitoring the chat box. Okay. So with that, I hope if you feel uncomfortable, that's a good sign. That is saying you are learning. So when you feel uncomfortable, sometimes maybe frustrated, don't quickly blame professors, okay? One of the key reasons you got that feeling is because our minimum requirements in the prerequisites. Ideally, in between these prerequisites to the mechatronics, I think we should at least have electronics, the course on electronics, okay? We should have signal and systems, okay? And hopefully they will have control one, basic knowledge in the controls. But I know that many of you are already parallel taking the vibration and control. That's a good side. It will mutually help. These two courses will mutually help, okay? And another good news is this textbook is free PDF for everyone, so you don't have to buy a copy. So this is good. But if you insist to buy a hard copy, yeah, you can go through this link. But I think the PDF will be enough. So good. There are different tastes of mechatronics. Like I said, some people put emphasis on embedded systems, software side, concurrent. But I think from foundational course, we should have a broader coverage without dig too deep in a specific topic, okay? On the other hand, this book is good in the sense they put emphasis on embedded systems. Good news is our lab will put emphasis on embedded systems, okay? Embedded systems. So we have two TAs. One is called named Furkan. Next week, I joined their lab sessions, so you are going to meet them. So we are going to have office hours 1 to 2:30 from Wednesday to Friday, jointly with the TAs. We're not going to use this Zoom. I'm sorry, I should edit this. I originally planned to use my private Zoom link, but I think it's a good idea to use the Zoom link from within CAT course. So I changed that, okay? So our lab sessions is Wednesday and Friday. So I know you use the different sessions. So here's an outline. Today we are here, week 01. We are doing the intro, okay? We are doing the intro. I want to tell you that the definition of mechatronics is no unique, all agreed upon definition. So I want you to look for more definitions of mechatronics. So that's homework number 1. Go to the websites, find out your favorite mechatronics clips, and summarize top definitions you like. Okay. Then we have a large 3 weeks, about 3 weeks. Okay. How I do this? Okay. Well, we have 3 weeks on components, okay, elements, components. After that, we are going to do signal and systems. modeling and simulation. Okay, we probably will speed up a little bit because our labs are all in distant remote. So we need heavily rely on MATLAB Simulink. Good news is we are going to have those interactive labs. And in the end, hopefully you are going to design some of them for the next year, for the future. So you can see I'm doing the modeling simulation, signal system, control system. So these two are supposed to separate courses, okay? Separate courses. In the component side, the microelectronics, op-amps. So we're going to cover some of that, okay? Then we have a spring break. So I'm going to give you a take-home midterm exam. It's a form force you to summarize up, okay? Then after that, we're going to talk about digital controls that you control using the microprocessor. What are the things there? Sample data control. And what's the consequence of sampling? Okay. Then we cover sensors, we cover actuators. Then in the end, I'm going to bring you up front about what's the trending topics, okay? Then we have exam. So the exam, you can see here, I give you a pre-warning. If you do everything perfect, but you didn't do a good job in final exam, say for example, you only get 10%, then you are kind of B or B minus, okay? So what I mean is the final exam, I'll give you previous year's final exam to practice, okay? That means you have to do the homework yourself. If you do well, you should be fine, okay? You should be fine. I know there are some floating solutions there, but please don't use them, just do it yourself. Otherwise, in the final exam, you'll be in trouble because we are using a closed book exam, okay? And again, lab is 30%. If you don't do a good job in the lab, then you are going to not to the A, okay? Grade. So, and homework is 20%. Quizzes attendance is 10%. So you have to earn bits by bits. If you want to get an A, you have to be good at everything. If you don't do a good job in lab, don't do a good job in final exam, you may fail this class easily, okay? Easily. I know there are some saying, say, oh, Dr. Chen is an easy meet, easy professor. Yes, I'm actually very easy. I always try to give you highest possible grades. If you show me evidence you learned. New lab today, yeah. It's final cumulative. I don't know what do you mean, cumulative. Yeah, just final is just one exam. It accounts for 30% of overall of your grades. Okay. Lab is asynchronous, please. Okay. It's like as if we are on campus. Okay. It's only we don't have a physical circuits for you to play with. We use MATLAB Simulink. We put a lot of time designing that lab, so you should be able to learn a lot on this. So don't worry. So if you want to get A+, you know this grades. So we are going to follow this one to give you a grade. So, but here I want to give you a promise, okay? If you attend office hour, we are going to log every office hour who attended, okay? So we'll keep that record. And we see if you attended more, we'll give you some one-step bonus. So say, for example, your final grade is a B minus, but I checked, oh, you attended my office hours many times. So yeah, we can bring you to B, okay? All right, this is called one step, okay, bonus. Encourage you to interact with our TAs and myself. Okay, I'll be there. Please keep, otherwise I sit here in a Zoom session 1.5 hours and very lonely. Yeah, so the reason I want to combine my TA with me to do the office hour in the Zoom is to make sure I'm not so lonely. At least if you guys don't come, I talk to my TAs. We can chat. Make sense? All right. So, okay, I'm willing to help you for your success in learning. If and only if you are willing to learn and you show evidence you learned, okay? I'm serious. I'm very easy. Don't force me to give you an F, okay? If you get an F, you probably deserve it because there's no way I can save you. Yeah. So, all right. So any questions at this point? Again, I'm easy, okay? I'm easy. I'm not so. I'm not a killing professor. I'm not going to kill you. I'm here to help you to learn, so that you can feel proud that, hey, I learned mechatronics from Dr. Chen. All right. So, yeah. And I think others are standard. So if you need any help, so we have a course goals defined, learning outcomes all defined. Then probably we should revisit this list to see, oh, did we really learn all these? So this is like a contract between you and me. So I guarantee you guys, when you visit back about this list, you'll see that, yeah, I know this. See? Okay. Oh, 13. Okay. Okay. And we also have some standard policies. I never wrote this one. I use this, what they call boilerplate text. I just use them. So it's a standard. I didn't add or delete anything. Academic dishonesty statement. So I think in this difficult time, we assume everybody will be honest to yourself in learning process, unless otherwise, okay? Okay. For example, if you submit something and you are wrong and you made exact the same mistake as others, so then we'll ask you, what's going on here? If you have any requirements, there is a dedicated resource for you to get help when you need a disability accommodation, okay? So it's called Student Accessibility Service, okay? Don't feel shy, just ask, okay? Okay. So any questions about syllabus? No? Then I'm going to start to show you some interesting slides and interesting movie clips, okay? And I'm hoping that in the homework number 1, you are going to show me some interesting movie clips from YouTube regarding mechatronics, okay? Then I'm going to compile the homework number 1 and form a big volume and we share back. So write it nicely. Is carry your name. Then we put together as a single PDF. So we share back to all others. Okay, good. So I like that, in fact. So that means when you learn something, you share back, and you have class size of 60, then as if your efforts were amplified by the amplification gain as 60, okay? So you spend 10 minutes as if you spend 600 minutes, all right? So do it seriously and let people feel good about your work. Like, wow, this guy is very good, serious, okay? In a summary, on the other hand, here's my statement. If you go through all the elements of these lectures, quizzes, homework labs, take-home exam, final exam, okay? Just spend enough time, minimum 9 hours a week, okay? It is very, very difficult to fail my class, okay? Okay, so make sense? Okay, all right. So let's say it's hard to fail Dr. Chen's class, okay? Say it. Okay. All right, so we are going to move to the, let me see, it's 21. So week number 1. Oh, I want to say a few words about our textbook. I did a lot of evaluations. So this is our textbook. It's about 2.5 pounds if you do a hard copy. So 1 kg. It's about 900 pages, okay? So I want to draw your attention about this, okay? It's a foundation course, okay? In other words, after you have taken this course and spend 9 hours a week investment, in the end, you transform yourself to be a ready workforce for very wide industry. So driverless car, like manufacturing, like instrumentation, aerospace, you name it. We're going to mention those sections to you later. So it's amazing, okay? So of course, we cannot cover every page, every section, every chapter even, but from what I see, this one, so talking about the basic ideas, mechatronics engineering, elements, components, then they start to talk about modeling of your mechatronic systems. We're going to talk about modeling, what are the purposes, why modeling, what kind of models, okay, classification of models. Then after that, you can see we have signal conditioning, signal processing, and component interconnections. So you have a subsystem connect to another subsystem, you know, put together, you have a working system. So that kind of interconnection, we should discuss about it. I highlighted one thing, is called impedance matching. It's very interesting. A lot of people didn't know this, okay? Didn't know this. In the circuits, you probably learn something called maximum power output, okay? So there is important thing regarding your internal impedance versus load impedance. You have to match such that the source will pass the power to the load in the maximum possible way. Okay, what's that? What does that mean? We're going to seriously study this thing, okay? Then there are something regarding error analysis. We'll briefly do something here. And sensors, actuators, these are the sensors, okay? Then all these actuators, okay? Then there's some digital hardware microprocessor, like what I call digital controls. Then we'll have control systems, okay? So you put together and make it under control so that the system will behave as we desired, okay? Then case studies. Okay, I think logically this book covers everything we want. So we are also going through this way, but different thing is I put sensors actuators in the later part, okay, in the later part. Because we need to put the signal system in front. So then there are some Appendix A, solid mechanics. You probably learned ME142Sp21. And the transformation, Laplace transform, you should visit something on that. Then probability stats, probably this is not important because you all learned this. And software is MATLAB Simulink, MATLAB Simulink, okay. Let me say something regarding MATLAB Simulink, okay. So a lot of students may say, oh, if I have a hammer and screwdriver, that would be nice, it's a tool. But software is also a tool. And there are two types of tools. One is academia, or mainly used in universities. One is industry. So a lot of people misunderstood that MATLAB Simulink are just for academics. That's totally wrong. In industry, people using this on a daily basis, MATLAB Simulink. So invest your time to be literate, at least, about MATLAB Simulink. To me, today is like MATLAB Simulink is essential skill, okay? You don't have to take a dedicated course to learn MATLAB Simulink. You just pick up yourself. This is exactly the same as you don't take a dedicated course to learn how to use your calculator or take a course to operate your iPhone, okay? All right, just pick it up, okay? Try and error. You are not going to damage your computer by playing the MATLAB Simulink, do something. So just invest time in it. Watch some tutorials, read some menus, and try some codes, okay? Put your hands on it. Unfortunately, I probably don't have time to do the LabVIEW side. LabVIEW side is for doing virtual instruments, okay? Virtual instruments. So LabVIEW, the views, VI stands for virtual instrument, okay? E is like environmental or something. W is a workbench, from my understanding. So LabVIEW. But I think LabVIEW idea is similar to Simulink with the block diagram based coding programming. So I went through this with you briefly. So this is our main reading of our textbook for the semester. It's just 900 pages, okay? But if you are giving just the book you learn yourself, it probably will spend very long time to really grasp the essence, the foundations of this course, okay? The foundation. Take a long time to pick up. But taking a course like that and follow my way of giving the contents, in the end, you feel like this book is not that thick. It's very thin, okay? It's very thin. So that's what we call, when you read a book, initially you feel it's so thick, but as time goes, it's become thin, okay? Thin. That means you grasp the essence of the book, okay? So on the other hand, you should read the book, okay? I know a lot of people doesn't want to read books, That's not right. So the reason we have a homework is to force you to go back and check the textbook, read that part, so you will be able to do the homework. Okay. Okay. So that's textbook. So let's go and take a look of Mechatronics Introduction. So this is deck of slides is very classic, and we should not ignore. Let me do this. So I said this is actually in a course syllabus. Defining what is mechatronics, we use this way. One word is synergistic, combination of ME, EE, control E, and computer through the design process. Okay, through the design process. All right, so we have basically here three circles. Let me see if I can use my pen to draw. No, I don't know why I cannot do this. Let me see. This is because I have to be on the comment mode so that I can use my pen to write. Yes. Let me see. Now I can write. So you have so control systems. Okay. We are missing a course. We have a computer engineering. We're also missing a course. For mechanical engineering, you probably learned a little bit on statics dynamics. So I don't think we have learned electronic system. So electric circuits is still on a very abstract level. Electronic system is more on the microelectronics side. Okay. So those intersection part is our mechatronics. Okay, mechatronics. Okay. And I'm going to share with you the industry sections. So defense, medical, aerospace, automotive, and so on and so forth. So let me give some examples in around your house. Is a refrigerator a mechatronic system? Yes. Is a rice cooker a mechatronic system? Yes. Is your dryer and a washing machine mechatronic systems? Of course, yes. Okay. So you can use many of the examples. Okay. Is your garage door opener a mechatronic system? Of course it is. And so on and so forth. Go on and on. So it's hard to see useful electromechanic systems that are not mechatronics. So is your car a mechatronic system? Yes, of course. In your car, you have control system, you have electronics, mechanic system, you have computers. Okay. Do you roughly know how many computers in your car today? Do you roughly know? Can you guys 3? No, more than that. I think today it's about 20. 30 in prayers? Really, Daniel, how did you know? Yeah, I think 20 probably is not so exaggerated. Yeah, 30. No, I didn't count, but many. You think about your power window. one of the power window is already a Mechatronic subsystem itself. Google says about 50. That depends on how much you pay for the car, like sports car, SUV, and okay. I trust Google then, but I think 20 is probably a regular number. So you have many subsystems that are also Mechatronics. So why we need to learn the Mechatronics? Tesla almost most likely 50. That could be. Tesla is more integrated in that sense. Yeah. Nice. Thank you for. That's a good thing. You can see I learned something from you. I didn't want to put a 50. In my mind, it's on at 20. Yeah. High-end car should have 80 plus. Could be. So in the future, in your house, I think it will be easy that you have over 100 CPUs. Okay, it's easy to have more than 10 hard disk drives. Okay, think about your smart TV. I think it's more than one CPU there. Yeah, nice. Okay. Good discussion. So I like this type of interaction. Okay, don't feel bored and sleeping. And also, if you attend, please pay attention. Don't think, oh, I'll make up, I watch it. Trust me, you are not going to watch it. I know it. Okay, so if you budget the time to attend a class, best to use the time. Don't do other things. Keep yourself engaged. Take some notes to prevent you falling asleep. Okay, take some physical notes. Okay. All right. So I have some secrets I want to share with you. But before that, let's go through a few more slides, then we move on. So in fact, the Mechatronics is already, so I'll give you a hint that, so all these 4 circles, one circle here, one circle here, one circle here, one circle here, all these 4 circles are already embedded in this word, okay? Do you guys know that? You are learning something new. I'm telling you my secret now. I think I'm probably among the very few in the world figure this one out. I don't claim I invented it, but there are few people, very few people knows this. But all my classes in the past, they know it. So let me show you. So how the 4 circles embedded in one word. So the first circle here is a Mechatronic system. It's a mechanic system. It's here. It's mecha. Okay, everybody knows. Okay. So electronic system. So the tronics is here. Tronics. Okay, is here. Okay. Second circle. So then where is control system? This is control system, right? Okay. So then what is the CS? And yeah, it's also here. So computer systems. Do you like it? So yeah. So Mechatronics already contain these 4 circles. Okay. Big breath. Okay, let's move on. Then we'll watch some movies. We finish today's lecture. Okay. So I already shared with you my. Interesting. I cannot put this one in the full mode. So is it okay? Too small? I cannot move. Oh, I can do this now. So the reason we must talk about Mechatronics is driven by a 3-letter word. It's called time to market. Okay, time to market. So you have a good idea and you do a prototype, and then you tell the investor, and you mass produce them and get into the market. You have to be fast, you know. Otherwise, you lose the competitiveness, okay? And people will not give you money, time to market. No, that's not on the quiz yet. The first quiz, there probably will be in the future quiz, maybe in the final exam, okay? I'll have a section of acronyms, okay? So then if you say, oh, sorry, I forgot what is a TTM, then what does that mean? You didn't attend my class. You didn't watch the recorded lecture as well, okay? You don't know what is TTM, okay? So Mechatronics will help you to speed up the TTM, okay? Time to market. So another point is the cost and function ratio, okay? So meaning you spend the same amount of money, but you are going to buy more, okay? So is it possible? Yeah, think about the disk drives. I work in the disk drive industry for 1.5 years, 18 months, yes, 1.5 years. Disk drive, today you spend $100, you buy how many gigabytes? Okay. In 1997, I bought a 3.2 gigabyte hard disk drive at the cost of 350 Singapore dollars. It's around $200, I think, at that time. 3.2 gig. Okay. Today, this money can buy 3 tera. Okay. Terabyte. So, or maybe more, 8 tera. So it's like $1,000, 3 orders of magnitude difference. How they achieve that? It's exactly because of this increased complexity and reduced cost. Okay. So the product itself is getting more and more complicated. The cost is going down. How this could be? So to really meet this trend, you have to use that mechatronics design principle. Okay. So it's not just to add some additional function. Okay. You need that synergy. Okay. You need that synergy. This is where we need to talk about mechatronics. So this is called over the world state. So previously, 20 years ago, so you have different departments, they do their design, they go to manufacturer, then they just assemble them and yeah, have a product. So later, they are talking about concurrent engineer. Why we cannot put a design manufacturer together, but they still have that division between those 4 things. Remember 4 circles? These 4 circles, okay? So these 4 circles are here: electrical power, mechanic department, control, and computer. So now they are just removing that wall and just do mechatronics way, okay? So in other words, we have a higher standard to engineers. High standard for engineers. They have to have this type of mechatronics way of thinking, foundational training, like you are taking right now, to meet this wave. Meet this one: increased system complexity, reduced cost. Okay. Otherwise, you cannot survive. Okay. Not survive. So that's called design challenge. You need a cost-effective incorporation of electronics, computers, controls, mechanic system. We need a new way of thinking, new approach towards the synergistic design. So today, you want to be a modern engineer, okay? You must learn the synergy of mechatronics, okay? So for example, you design the temperature sensor, you not just work on the sensor, you should also know the whole system. The sensor is used to which system for what kind of performance in a closed loop setting, okay? All right, so it's difficult because you have to have the big picture view of the system you design a sensor, the sensor used in the system. So you have to know the system before you design the sensor, okay? And also the system, you have different elements, components that interact with each other. So how those interactions, so you should know that. You also need to know the modeling without just thinking on the real thing. Especially some of the stuff you cannot try and error in a garage, okay? For example, you have aircraft, so you cannot have a pilot try the aircraft and crash over and over. It costs life, okay? You cannot do some dangerous things on the nuclear power plant. You have to use it in a modeling simulation session. You don't want to directly try something on the nuclear power plant, okay? It will cause disasters, okay? In particular, when you have a closed loop system, closed loop system have two, so you want to make the system to behave like you wish, okay? Say for example, you have a room temperature control in your house. So you have set point on the wall, so the system will adjust temperature. So it's called temperature regulator. You regulate the temperature around your desired point. But on the other hand, if your control system do not do a good job or some fault, so you will see the temperature going up and down. You probably experience that. So some of you take shower, sometimes the shower is good, so temperature is maintained well. Sometimes the temperature, when you take shower, temperature getting suddenly too low, then suddenly too high, feel hot. So that kind of experience, I guess you had in some of the motels, and so they don't have a pressure control well, and then you have that kind of unstable temperature or oscillatory temperature, okay? So in other words, even if your system is supposed to be stable, after control, the bad control will make good system unstable. That's bad. That's bad, okay? So therefore, mechatronics design, you need to have system perspective, interactions, modeling, and be aware of that system could be made unstable. On the other hand, you say, oh, I made it stable, it is working. So then you need to talk about, yes, good, so you are stable. But usually people also want to learn how far away you are from being unstable, okay? So just like you have a boundary in here, so in here you say, oh, I'm stable, but here is not stable. So then what is it? This is the stable, unstable bond. So what is the distance here? How far away you are from being unstable? So this is called stability margin problem. So then not only you design a system that is stable, but also you need to make sure that you're stable with enough margin, okay? Okay, so this is our beauty of control system. We are going to live with that later on. So the key to success here is, yes, we need hardware implementation. We need We need experimental validation, but the computer simulation without experimental verification is at best questionable, at worst useless. So how to answer this question in our COVID time? So because we heavily do this side, we're not doing this side. So how we are going to survive in view of this picture? How? So are you curious about my answer? Oh, you want to use Chernobyl? Yeah, Chernobyl is exactly the disaster due to an unstable system. Yeah. So don't worry. If we can make sure the model, so this is called physical. But we also can do something. If you want to Google, I wish you will do, is something very popular in the recent 2-3 years. It's called digital twin. Okay, so digital twin. So if you can make a digital version of your physical system, we don't call it a model anymore because it's so authentic. It is so authentic. It is a digital twin of the physical system. So therefore, from that perspective, this physical system, we should call it what? It's physical twin. Then I have a digital twin. Okay. So the digital twin is a big topic. So I suggest you Google this one and learn some basics. Okay. Description. Digital twin. So I'm going to, in the last lecture, I'm going to lead you towards the future digital twin. Yeah. So as our, I want to say something here because I already here, I'm talking about digital twin. So you can see our lab has a digital twin theme of work. So take a look what we have been doing on research side. But however, I don't want to distract you from here because you really need these foundations before you do more cutting edge type of work. So I just want to assure you that don't feel the COVID is affecting us. We are thinking about using digital twins to make a more authentic version of physical twin so that when you do the experiment, on top of this, you cannot even distinguish, is this a digital twin or is this a physical twin? Make sense? Yes? So, good. So we only have 10 minutes. So let me start to show you some videos before we finish up. Actually, we do have more slides left over, but you need a sort of a balanced, I think we wish to say balanced foundation in mechatronics. Balanced foundation is the key. So that's why I hope you should have all these type of skill set, like modeling, analysis, and design. So in fact, if I don't do this design and I start to call this one M, A, and D, it's called MAD. So I hope everybody will have some skill set covering the MAD. Do you know that I wrote a MAD book? Okay, so let me show you. So I'm not trying to promoting my stuff to you, but I just in a context. So then you understand, okay? So if you say, oh, I only know how to do the modeling, sorry, that's not enough. Yeah, I also need to learn how to do analysis. And you also need to learn design. So so that you have a system. And then I already said, experimental validation on digital twins or physical twins are key. So hardware implementation is important again. Without hardware implementation, can we do that? So there is a term. I hope you understand this one. So it's called HIL. Have you heard about HIL? Can anybody tell me what's the HIL? It's called hardware in the loop. Okay, so you have a control system, you put that hardware in that loop, so you do the control. So then, sorry. There is also something called SIL. It's a software in the loop, okay? Also, there's something called PIL. PIL stands for processor in the loop. Process. No, I'm not going to put this one into the final exam, don't worry. But you should still know, right? Process in the loop, processor in the loop, sorry. Processor in the loop. So that you tried everything, and I tried to use a microprocessor. So then microprocessor and my hardware, so working together. So then you can deliver to your users. It's called a customer deployment. So before you deploy that to the customer, you can also do this type of thing. So then sometimes they also use this word. I like it. So basically, you say, "Oh, this system is done and it's taken into operation." You can, "Oh, this is commissioned." I like that term. So time to watch some movies. Then we can finish today, and I hope you like my style. But if you don't like my style, please give me feedback. Say, "Oh, that part I don't like. I don't like the way you deliver your lecture. I don't." So give me some feedback. I'll try my best. So my job is not like do a copy of this chunk of knowledge to your brain. That's wrong. I'm trying to stimulate your interest. So make you think, make you want to invest your time on this subject area, okay? And you drive yourself. It's good so far? Okay, thank you. I enjoyed the lecture. Thank you. We recorded this. So this feedback is called positive feedback. So later you know that if you have a positive feedback in the loop will be unstable. So you should give some negative feedback. Okay. So let's do something. So you know that my lab is doing a lot of drone research. Right now we have a parallel course offered on the ME143. It's a drone course. So for some of you don't want to do general mechatronics, you want to narrow down to a specific mechatronic system. It's called drone unmanned air systems. So you can do that. So I want to show you something we worked in when I was in Utah before I moved here. That movie probably took in 2007. Yeah. So I'm sure you should hear something. You don't hear? Oh my God!
Air is a remote sensing platform that is completely autonomous.
That's the problem.
It takes off.
Do you hear
by itself.
the sound?
It flies around.
You can hear.
To a pre-programmed flight plan all by itself and lands completely autonomous.
Why?
And while it's flying, it
I
captures
know
visual
that.
infrared
I know
imagery
that.
to make
What's
maps.
going on? Yeah.
After takeoff,
Yes.
the plane automatically goes into a pre-programmed flight plan and takes pictures of the ground every 4 seconds.
After its flight plan, it comes back to the ground station.
After about an hour's worth of flight, we may have 350 to 400 images. The best solution is to take all of the images together,
Stitch them together to make a georectified mosaic.
What we can do is not only give them the visual imagery, but we can give them the near-infrared imagery. But you can also then take it a step further and actually use the two images to automatically classify the plant species that you're interested in.
So that's give you a taste of specific mechatronic system in action. So this is also a main reason I moved to UC Merced, because you can see we have 6 months of snow coverage in Utah. The drones cannot see much. So here we are in the center of the agriculture, okay? So we can use this one for agriculture research a lot. So I'm having a good time here. I never regretted I moved. Another reason is because of you, because I can empower many students by taking research experience with us. We flew the drones together in the fields. So let me see if I can do this.
Okay, ready?
So this is kickstart. So my point here is, can EE people or computer science people who only knows how to do mouse clicks do this type of auto launcher? No way, because design that launcher, you need a lot of mechanic knowledge, mechanisms, and computing the force and so on and so forth. So I think you guys should feel very proud of yourself. So you can do things, you can do things that CS and WE people can do after you learn the mechatronics, okay? But on the other side, you can do something that, like mechanism design that CS and EW people will never be able to do. They don't have that training, and it's hard for them to pick up. So that's why that's why I'm staying in the Department of Mechanical Engineering. So I was in the EECS. So you should feel proud of yourself. Now you are picking up, and you will be more valuable than EE and CS people. Okay. And there's also a joke. Let me see how time to tell you the joke. So mechanical engineering is more valuable. Okay. So relative to the civil engineers, people laugh at them. So civil engineers building targets to be destroyed by things built by mechanical engineers, like rockets. Okay. So I have some more. Maybe we can take a look at this one and then we can finish. So this is the vehicle we designed. It's called T3 vehicle that can do omnidirectional. And so it's a 6 legs individually actuated. So therefore they can reconfigure themselves in the different ways. We'll finish in 1 minute, okay? So you can see they can change the configuration. Therefore, they can negotiate with the terrain condition very well, and then It just can spin in place without any turning radius. So this is called omnidirectional vehicle. Another idea is you can go to a slope, go on a slope with a slope, maybe unknown slope. So there's a way you can maintain the back still level. So you have a glass of coffee put on the top, on the back, will not get spilled, right? So, so lots of collaborative work, collaborative controls and sensing actuation and complex computational methods. So to do that, you need a mechatronics design. You cannot build in the middle and say, oops, I forgot that. So let's redo it. You have to have a synergistic view from the beginning, okay? So they spin in place on the slope. That will never happen. This is the world first. It happened in 1997. When I was not joining Utah, I joined Utah in 2000. Okay, we finish here, and let's see. I stopped sharing. Oh, I did 1 minute more. So in the future, I promise I'll finish on time. So I know everybody is on some schedule. Any other things? And we want to say goodbye, okay? Mechatronics, feel proud of yourself. Well, let's begin this journey together. Have fun. I will meet you in the lab, first lab next week. And I'll meet you this Friday as well, okay? Bye-bye. I'll post the video as well, okay? Bye, take care.